Our next multiplication strategy that we are going to talk about is called the area model. And to take your notes for this, you are going to need a pair of scissors, 3 colored pencils, a glue stick, one of these. This says area model on it, and that is it. So go ahead and pause the video and get your materials. And now that you are back, we're going to start with the area model paper. So I'll move everything else out to the side. If you want, you can color here, and what I'm going to do is color each of these 3 examples a different color and then cut them out as well. We'll be writing on this, but if you want, you can get your paper colored. And when you do, it'll look something like this. And again, I'm gonna set these to the side just for a minute. And I want to look at this example here and talk about what the area model is and what it means. If you've ever seen an array, it's very similar to an array. What I like about this one is that we're going to be using grid paper, which is very uniform and it uses exact squares. You can color it, you can see it visually. And so if you're the kind of learner that really likes to be coloring and see things, then I think this strategy will make a lot of sense for you. It's especially helpful with smaller numbers, but as we move on to multiplication and you get into double digits, I can show you how to do it without coloring in individual squares. But let's read this. It says, one way to show multiplication is by making a grid. And this thing with lines horizontally and vertically is a grid. Use one factor, and you know me, I love to circle our vocabulary words. Let's make our factors one color. So here are our factors, 5 and 3. And remember, a factor is just a number that is multiplied. So use one factor for the number of rows. So this is one thing we'll be doing, is making rows. I'm going to do this in dark blue. And another factor for the number of columns. So for this example, I will use orange for columns. So counting up all of the squares will give you the product. Vocabulary word. Oh, you know what? I do need to use a different color for that. I'm going to go ahead and circle product in orange because the product is our answer. So our example says that 5 times 3 is equal to 15, and yes, there are lots of different ways we could prove that, but today we are using the area model to prove that. So remember here it says to use one factor for the number of rows. So I'm going to go ahead and use this first factor, 5, in my row color, which I chose blue. And rows go across from left to right, so I need to make 5 of these blue. So here's one row of 5 and 2 rows of 5, of 3. 3 rows of 3, 4 rows of 3, and 5 rows of 3. Okay. Now it says that was the number of rows. Use one factor or the other factor for the number of columns. So I'm using orange for my columns. I'll just put a little square around this guy. And columns go top to bottom. You can think of a column that would support the roof of a Greek building. Those columns run vertically up and down, just like your vertical up and down. So this second factor is going to be a column, and we need 3 of these columns. So here's 1, 2, and you can see I'm just sort of outlining them so that you can see how the colors overlap, and 3. So another thing I think I will do is number these, column 1, column 2, and column 3. And down the side here, I'm going to label row 1, row 2, row 3, row 4, and row 5. Now, if I want to prove that 5 times 3 equals 15, I can actually add up my squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or you could count 3 columns of 5, 5, 10, 15, but either way you should get 15. So now that you have your example completed, go ahead and get your grid paper and glue this to the top. I chose to do my gluing last because it's really hard to write on the paper when it has wet glue underneath. You might have noticed that last week. So I'm going to try this where we do all our writing and drawing first and then glue. Okay. And let's lay these out before we glue to make sure we have them where we want them. I've got 8 times 5, 6 times 6, and 9 times 3. Let's see, I'm going to need plenty of room for all 3 of these. I'll do 8 times 5 first. I will do 6 times 6 over here, and 9 times 3 down here at the bottom. Let's see, this 8 is going to be 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. That does leave me enough room. Now this one's 9 rows. I will not have enough room, so let me switch these. Okay, I need 6 rows. 1, 2, 3, 4, 5, 6. Okay, a little careful planning here so that you have enough room under 8 times 5 for 8 rows, enough room under 9 times 3 for 9 rows, and enough room under 6 times 6 for 6 rows. I think I've planned enough room here. Okay, I need 6 rows. 1, 2, 3, 4, 5, 6. Okay. So there's where we're going to do the example for 6 times 6. I'll do 8 times 5 up at the top. And 9 times 3 over to the side, so that we have plenty of room for 9 rows of 3. Maybe you're starting to picture what that might look like in your head, what kind of rectangle it might look like. Okay, when I'm done gluing, I turn down the glue, pop on the cap until you hear that lovely click. Okay, let's do our first example. So I've got 8 times 5. This is going to be 8 rows and 5 columns. So I'm going to start by labeling my rows. I think that might help. Let's see, I'm going to use a darker color so you can see. Here's row 1, row 2, 3, 4, 5, 6, 7, 8 rows. And how many columns? Yes, 5 columns. 1, 2, 3, 4, 5. Okay. I'm going to color these a different way than I did up here. I'm going to try this. I'm going to try just sort of doing a line. So here's row 1, row 2, row 3, row 4, row 5, row 6, row 7, and row 8. And I know it's going to be 1, 2, 3, 4, 5 squares because I have 5 columns. Let's show those 5 columns. Here's 1 column, 2, 3, 4, and 5. Okay, I feel like I want to show this a little more clearly. I'm just going to color in these 5 columns here and the 8 rows here. And you'll always have a rectangle when you're making an area model. So here we've got 8 rows, 5 columns, and let's count up how many we have all together. Remember, these are rows of 5, so I can count 5, 10, 15, 20, 25, 30, 35, 40. Great. I think I'll write that here. 40. So 8 times 5 equals 40. All right, so pause if you need more time. If not, I'm going to move on to this next example, 9 times 3. How many rows might we draw for this? Thinking of our other examples, we use one factor for the number of rows and one factor for the number of columns. So really you could choose either, but my brain tends to think in order, so I always think rows first and then columns, and that's actually something that might come in helpful for you later on when we do coordinate graphing, especially in 5th grade. But anyway, for now I'm thinking 9 rows and 3 columns. So let me label my rows first. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to have 3 columns. 1, 2, 3. So if you can visualize what this will look like, kind of like a New York City apartment building, it's going to be tall and skinny. So here are my 3 columns. I'm going to color this differently because I want you to see that there's no one way to do this. Lots of different ways. I'm not going to color it in all the way because I want to see where the colors overlap. All right, now I'm going to do my rows side to side. All right, now I can count these up. I can either count by 3s or by 9s. If I wanted to count 3 9s, it would be 9, 18, 27. But if that's too big of a number, we can always count by 3s. 3, 6, 9, 12, 15, 18, 21, 24. That's right, 27. So 9 times 3 equals 27. All right. Knowing that, can you think about 10 times 3? If there was one more row, how many would you have? Well, there are 3 squares in a row, so 28, 29, 30. 10 times 3 would be 30. All right. If you are ready to move on, we will do our last example, 6 times 6. So this one's pretty straightforward. It doesn't matter which order we go. There will be 6 rows and 6 columns. I will put my rows here. 6, 5, making sure I have enough room. 4, 3, 2, 1. Just barely enough. And I'll have 1, 2, 3, 4, 5, and 6. All right, same thing here. Here are my columns. Columns go up and down. Think of Greek architecture. Oh, these kind of do look like Greek columns, don't they? Well, maybe if you squint your eyes. All right, here are my rows. They go side to side. You can color these in any way you like, but you should end up with a certain number of squares shaded that equal the product of 6 and 6. So let's see, either way we count them, it's 6 and 6. I know that 2 rows of 6 would be 12. Here's another 2 of which is 12. 12 and 12 is 24. And another row of 6 would be 30, and one more row of 6 would be 36.